So we have a velocity field. And it's not just in that slice, of course. It's everywhere here. It's wherever these points basically were. This velocity field we can use to advect. Now you could literally take this smoke, or this fog, as a source into a pyro sim, and you could literally source this velocity field as well. But what's really nice is that we don't technically need to. We can do a VDB advect here. VDB advect is really cool. It will take, again, the VDB to advect, which for the 100th time is a smoke, and it will advect it by a velocity field. And right now it's mad. Missing velocity grid. We'll tell it that, oh, we're not even pointing to the right thing. Yeah. Okay, now it can be mad for a different reason. Which is that we still haven't actually pointed to the velocity field. There we go. And now it will work, at least, or we don't see it complaining about anything anymore. So is this doing anything? It is. If you look real close, it is. It's doing something. Not much yet, though. What we want to do is basically say, take a longer time step. It has this thing in here by default, but we can just go ahead and, well, we could break it. I'm going to instead say, if we change it to 2, the higher we make this, the more time technically has gone by. Time step is basically saying, look at this velocity field and move our smoke through that velocity field for this much quote-unquote time. The velocities do represent time. They are meters per second, basically. So the more seconds we give it here, the further along in that velocity field it will move it. However, by default, there's only one time step. So the more time steps we give it now, after that, the more interesting it will become. Because now it'll move it, then read where we are now in the velocity field, move, then read where we are now in the velocity field, move, and so on. So I'm going to say 16 substeps, only a little bit of time. But here's now where it'll get interesting. Let's make the actual point velocity. I'm gonna pin this for a second so I don't see it. So I'm still displaying the VDB advect, but I have the point velocity pinned. The more powerful this velocity field will get, look at that. See what starts to happen? Now we're getting a more and more interesting result. And as I scrub through this, you can see that changes as well, because of course the actual velocity field itself is changing. So the field that this fog is being pushed through is changing as well. Essentially what's happening is, in a sense, this is doing one frame of simulation. I'm going to unpin this now for a moment. It's doing one frame of simulation where it has 16 substeps, which we understand already from doing sims. And it's basically speeding up. How much time is being passed in that one frame is what's set here. And that's it. So it's kind of running a sim from one frame from beginning to end every time this is evaluated. So this is not running a sim from frame 1 to frame 162. It's just saying start over on every frame, just how all SOPs do. And it says on every single frame, start over, take this velocity field, have this much time pass, which is just some amount of value. This does not even have to be in terms of FPS. It could be any number. Doesn't matter. If I break this connection, you can see the higher the time step, the crazier it is. It's just this much time is gone by, and we're going to do 16 substeps, essentially simulated, if you will. So we get this shape. We've designed this shape from SOPs without ever actually going into a simulation. So I hope that makes sense. These are going to be the values that I end up using here, or at least we're not quite done yet, but I'm going to say that much time step, that many substeps, and then I'm just going to play with the actual point velocity itself. So I'll say point velocity will be 8. I'll pin this again so we can see. We can do things like change the pulse duration, which is how fast the actual change is. So the higher the pulse duration, the slower it changes. I can say the actual swirl size. Right now, there's pretty small detail here. I'm going to make the swirl size be much larger. So you can see, again, as we change it, the smaller the swirl size, the more detail there is. I'm going to say I want a pretty broad shape with the swirl size, but I'll reintroduce smaller features with the grain. So the grain can go up to 0.7, and the turbulence similarly will introduce smaller features. And so there you have it. So we designed this kind of flame licking kind of thing here. We could even say on the point velocity, kind of how we did before. Well, not how we did before. Let's just add our own velocity to this. We can have it kind of bias upwards. So I'll say like, so the flame is kind of up. It's lifting up off of it. And we can see that here. When this was 0, it was like that. But as we added velocity, we're biasing it up. It's kind of moving. It's moving up, and then it's being noised. So there you have that. Anything else we want to do for this? I would say the offset can do that same business that we saw before, where as we lift the offset over time, it looks like it's moving up. So the same idea from this, where it looks like it's moving up, we can do here as well. Or really on the points from volume. So I'm going to say the offset can also have this time business. So as time goes by, it looks like it's animated up, as you can see, like a flame might. We could even have it, go twice as fast. We should probably just make a flipbook of this to see. In fact, let's just do that. So I'm going to go here. This whole animation, by the way, should be 72 frames, not 240. So click on this guy. See, the end is 72. Apply. There you go. Save. So I'm going to click our little flipbook, and let's see what we get. It'll be hard to really say until we render, which is what I was saying earlier, where the rendering will inform the shape, will inform the rendering, will inform the shape. And really, in production, you'd probably be going back and forth quite a bit, because again, there is no physical basis to what we're doing here. It's just magic. But we won't really know what it feels like until it's rendered and composited. But this is a good place to start from anyway. So there you go. So it's kind of going up, as you can see, and it's also changing on its own, as is this. And these are going to kind of blend into each other when we render it. But we can definitely see that it's working. Pretty cool, right? The whole VDB advection thing. I think it's a fun trick. So this is what I wanted to combine here with the VDB combined. Like so. So now we still only have one density volume. It's just both of these things. And I chose maximum here. Oh, I should unpin this. I chose maximum here, by the way, because I don't want to add them on top of each other. If I added them on top of each other, it might just get very bright here where they overlapped, because they would literally be two high values added together. It makes an even higher value. By choosing maximum, I mean, I could literally just go to add here. Now it's kind of hard to see, but the maximum is just going to say if this effect was 1, let me hide this. If this effect was 1 here, and this effect was 1 here, then the final effect should just be 1 here still. I don't want it to be any brighter here necessarily. Maybe you do, but I don't. So this is the overall inner effect that we just designed. Let's see what this looks like. This is still going to get the same rendering treatment because you know, it's still being shaded by the same shader now that it's just one overall volume. So that's cool. Very, very bright. You know, before we used to see the statue. Now I can't see the statue anymore. So what I'm going to say here is the B, meaning the second input here, the B VDBs, we can make it, I can multiply it down. I might even multiply it down further than that. So that might be pretty good. If I look at the alpha especially, yeah, that now I can definitely see it. This is how it will really look when composited. This is the, you know, how present the volume is on those pixels. So I think that'll be nice to see. And you can see how fast it renders it, which is nice. We could reduce the intensity overall on here. I could say maybe the whole thing is too bright. And now we can definitely see the shape of the statue much better. We'll get a better idea as we go, but for now I'm going to render this whole frame range, and then we can move on to the middle part of the magic. The middle magic.